Hello, my topic is randomized algorithm. Before discussing any topic related with randomized algorithm, first we need to know what is randomized algorithm. A randomized algorithm is a technique that uses a source of randomness as part of its logic. Basically, it is used to reduce either the running time or the time complexity or the memory used, that is space complexity, in a standard algorithm. See, in this figure, normal algorithm, there is an input, there is an output. But in randomized algorithm, there is input and output, and random input is there. The algorithm works by generating the random number, that is, let's suppose this is RR, within a specified range of numbers and making decisions based on RR's value. Now come to the next point, and we need to know importance of randomized algorithm. Randomization is an important concept, and hence randomization algorithms are used in a variety of fields such as number theory, computational geometry, graph theory, and distributed computing. The inputs for the randomized algorithm are similar to those of deterministic algorithm, along with a sequence of random bits that can be used by the algorithm for making random choices. In other words, randomized algorithm is one whose behavior depends on the inputs, similar to a deterministic algorithm, and the random choices are made as part of its logic. As a result, the algorithm gives different outputs even for the same input. In other inputs, or in other words, the algorithm exhibits randomness, hence its runtime is often explained in terms of random variable. Basically, there are two types of randomized algorithm. There are two approaches. One is Monte Carlo, another is Las Vegas. Randomized algorithms are usually designed in one of two common forms as Las Vegas and Monte Carlo algorithm. A Las Vegas algorithm runs within a specified amount of time. If it finds a solution within that time frame, the solution will be exactly correct. However, it is possible that it run out of time and does not find any solution. On the other hand, a Monte Carlo algorithm is a probabilistic algorithm which, depending upon the input, has a slight probability of producing an incorrect result or failing to produce a result altogether. Now, come to the point, that is, what is Monte Carlo forms? The game Wheel of Fortune can be played using a Monte Carlo randomized algorithm. Instead of mindfully choosing letters, a players pick randomly letters to obtain a solution that is shown in this figure, that is shown in this image. The more letters of a player reveals, the more confident a player becomes in their solution. However, if a player does not guess quickly, the chance that the other players will guess the solution also increase. A Monte Carlo algorithm is given a deterministic amount of time in which it must come up with a guess based on information revealed, the best solution it can come up with. This allows for the possibility of being wrong, maybe even a large probability of being wrong in the Monte Carlo algorithm did not have sufficient time to reveal enough useful letters, but providing it with a time limit control the amount of time the algorithm will take, thereby decreasing the risk of another player guessing and getting the prize. It is important to note, however, that is the game differs from a standard Monte Carlo algorithm as the game has one correct solution, whereas for a Monte Carlo algorithm, the good enough solution is an acceptable output. In the previous slide, already I have told that Las Vegas algorithm runs with a specific amount of time, and Monte Carlo algorithm is a probabilistic algorithm which, depending upon the input, has a slight probability of producing an incorrect result or failing to produce a result altogether. Now, Las Vegas approach. A Las Vegas algorithm is a randomized algorithm that always produces a correct result or simply does not find one. Yet it cannot gives a guarantee that a time constraint. The time complexity varies on the input. It does however, guarantee an upper bound in the worst case scenario. Las Vegas applications or algorithms occur almost every time people look something up. Think of a Las Vegas algorithm as a task that, when the solution is found, it has full confidence that it is the correct solution, yet the path to get there can be murky. As an extremely generalized and simplified example, a Las Vegas algorithm could be thought of as the strategy used by a user who searches for something online. See, there is written. Las Vegas algorithm runs within a specified amount of time, and Monte Carlo algorithm is a probabilistic algorithm which, depending upon the input, has a slight probability of producing an incorrect result or failing to produce a result altogether. Now, there is an algorithm that is quick short. This is an example random quick short. The quickshot algorithm is a sorting algorithm which uses no extra memory. It uses the basis of divide and conquer approach. Basically, it has been solved by divide and conquer approach. We can say that algorithm operates as such. Choose an element of pivot using a random number generator. Create two subarrays of smaller than I and greater than I. Then performs quickshot on the subarrays, outputting full sorted one. In the worst case scenario, the pivot elements will be the first or last item. We know that insertion and removal that takes order of 1 and partitioning takes order of n. However, since if the pivot is first and the last of the partition will create two subarrays of size 0, since there are no elements passed on the last or before the first, and order of 1 of the size order of n minus 1. We can therefore deduce the running time as a pairwise comparison, and therefore will be the left with the running time of order of n squared. However, if the random pivot is not the first or the last element in the array, we reduce our time complexity. If the middle elements are selected as the pivot, the array will be partitioned in half each time, leaving us with a time complexity of order of n log n. Since the recursion tree is order of n log n, not n log n. This is only log n div, and each level takes order of n to complete. This also means that the average time complexity will remain at order of n log n, even though there is a 1 by n, 1 of n chance that it has average case occurs, since the depth of the recursion tree and time it takes to complete one level of the tree doesn't change. What are the applications of randomized algorithm? Sorting, load balancing, mathematical programming, graphical algorithms, enumeration and counting, de-randomization, parallel computing, data structure, algebraic identities. What are the advantages? Randomized algorithms are known for their simplicity. Any deterministic algorithm can easily be converted to a randomized algorithm. These algorithms are very simple to understand and implement. Randomized algorithms are very efficient. They utilize little execution time and space compared to any deterministic algorithm. Randomized algorithms exhibit superior asymptotic bounds compared to deterministic algorithm. In other words, the algorithm complexity of randomized algorithm is better than of most deterministic algorithms. Reliability is an important issue in many critical applications, as not all randomized algorithms are always give correct answer. In addition, many randomized algorithms may not terminate. Hence, reliability is an important concern that needs to be dealt with. The quality of randomized algorithm is dependent on the quality of the random number generator used as a part of the algorithm. Unlike other design paradigms, a randomized algorithm does not use a single design principle. Instead, one should view randomized algorithm as those designed using a set of principles. So, the disadvantages. The logistic of a randomized controller trial can be demanding. Some randomization effort may be predictable. There can be some probability or applicability issues with randomized controlled trials. This research method comes with some ethical limitations. Some research cannot be ethically performed using this model. The data does not show you the critical information needed for the results. Participants who would participate in the research are not always reflective of the demographic. It is an expensive proposition. Now, thank you. If you have any question, you can send by mail at abb.cs@brainwareuniversity.ac.in. Thank you.